Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic, we're going to look at a nice, simple aide-memoire for remembering some trigonometric values. In this topic, we're going to describe a simple pattern for remembering the values of sine of x for x is equal to 0, pi over 6, pi over 4, pi over 3, pi over 2. We'll also look at a slightly more general pattern for a slightly larger number of possible values. We'll then see how to quickly expand on this, but it's really not that necessary. Now, from secondary school, you probably understand that it's probably a good idea to remember these specific values of the sine function. And of course, from this, you can remember the values of cosine of x and tan of x for these values as well. I had a problem remembering these sometimes, and so in university, I actually came up with a nice simple pattern. If the GCD of k and 12 is not equal to 1, then there's actually a very simple formula for sine of k pi over 12. Specifically, it's square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. It's that simple. Now, these then simplify to the expressions that you're more familiar with in secondary school. But if you remember the first pattern, then you can quickly deduce the numbers in the rightmost column. And here's a fun one. If the GCD of k and 24 is not equal to 1, we actually also have a really nice pattern for sine of k pi over 24. Here you will see that it's just the square root of 2 plus or minus the square root of a sequence of integers. So we start off at the top with square root of 2 minus the square root of 4 all over 2, square root of 2 minus square root of 3 all over 2, square root of 2 minus square root of 2, and so on and so forth. And in each of the cases where one of these angles matches the angles on the previous page, the formula simplifies to the formula we saw on the previous page. If you want to get a few more angles, you can just use a double angle formula and use appropriate values that we've already calculated. But in all likelihood, that's really not necessary and way beyond the scope of this course. Indeed, you probably don't even have to remember the general formula on the previous slide. However, I was just giving that as an example as to how the pattern on the first slide can be generalized for a slightly larger number set of values. Consequently, in this topic, we've seen a few aide-memoires. So, if x is equal to 0, pi over 6, pi over 4, pi over 3, pi over 2, then we can calculate sine of x simply by remembering the square root of k over 2 for k equaling 0 through 4 respectively. There's a slightly more complex formula for determining sine of x for a slightly larger number of possible values, but the formula is not that much more complex. This is by and far what you will need to know in almost all cases. Here's some references. Specifically, I'm going to point out that the formulas for the second page is a pattern I've never actually seen on the internet. I was just looking at the patterns that I've seen and, oh, wait a second, this is how it works out. And then I used Maple to verify that yes, indeed, these values were indeed correct and not just approximations. Acknowledgments, the colophon, and a disclaimer. Cheers!